Okay, 14b, differential equations of different forms again. We're doing example 9, which talks about the acceleration a of an object moving along a line given by a equals negative v plus 1 squared, where v is the velocity of the object at time t. The initial velocity is 10, the initial position is 0, where x is given as the position of the object. Find the expression for the velocity of the object in terms of t, and an expression for the position in terms of t. Now I'll do this slightly differently to the textbook. So I'll take, I know a equals negative v plus 1 squared. So that's dv dt equals negative v plus 1 squared. Align your variables. So I bring the v plus 1 squared over. I left the negative on the right hand side. And now I need to integrate both. Now remembering this is the integral of v plus 1 to the negative 2 dv. This will just be negative t plus c. Integrating this one, remember we add 1 to our power. So add 1 to negative 2, we get negative 1. Divide by that new power. And we usually divide by the coefficient of the v, but obviously in this case it's 1. So it's negative t plus c. Let's multiply through by negative 1. So we're going to get 1 on v plus 1 equals t minus c. Just getting rid of those negatives. Now we could rearrange first and then find c, but I'm going to find c next. So to find c, I know that t equals 0, v equals 10. So I'm going to have 1 over 10 plus 1 equals 0 minus c. Then of course I'm going to have 1/11 is minus c, therefore c equals negative 1/11. Well, not a huge, super nice number, but it's not too ugly either. So 1 on v plus 1 equals t minus, now minus minus, so it's going to be plus 1/11. How best would I proceed if I wish to rearrange this so that it was v equals? Now, of course, I could rearrange this, and the textbook is quite happy with this arrangement. And just arrange it like that. It's an expression for velocity with t. I would like, though, often to put it as velocity equals. So how would we rearrange that? If I was rearranging, so this could be marked right, but if you wanted to rearrange, and how would that algebra look? I'd put it as 1 on v plus 1 equals 11t plus 1 over 11. Then it would be a simple, I flip both fractions, I get v plus 1 equals 11 over 11t plus 1. And then v equals 11 over 11t plus 1 minus 1. So it is quite simple if you need it to be in the form of v equals, or leave it as t equals. Oops, sorry about that. Now, what happens if we want to find the position? Now, this is where I think having it in the v is easier. So v equals 11 over 11t plus 1 minus 1. And we want to take that to position. So this is dx dt, 11 over 11t plus 1 minus 1. So dx equals 11 over, sorry about that, 11t plus 1 minus 1 dt. Integrate both sides, position equals. Now what is this going to be? Looking at this, the derivative of the denominator is 11. So this is really nice. So that's going to be ln 11t plus 1 minus t plus c. So even though we're thinking, oh, that's going to be a bit nasty, it actually works really nice. And we're told that when x equals 0 was when t equals 0. So what's c going to be? Find c. So that's going to be 0 equals ln 1 minus 0 plus c. Remembering, what is the ln of 1? The ln of 1 is 0, so therefore c equals 0. So we've got x equals ln 11t plus 1 minus t, which is pretty nice and easy for us to use. And that is example 9.